Hi there, Michael King here. Now we're going to look at how to calculate the payment on a mortgage, as well as to build out a mortgage amortization table. It's a little more complicated with a few more steps than doing a loan, but it uses the same principles. So let's assume you have a $500,000 mortgage with a 10-year term and a 25-year amortization. The quoted rate is 5% compounded semi-annually with monthly payments. This is your standard format for a Canadian mortgage where there is semi-annual compounding and monthly payments. In Canada, we use this distinction between term and amortization period, where 25 years is how long it will take to completely repay the mortgage, and 10 years is how long you will have fixed the terms initially. So at the end of 10 years, you will have to renegotiate and set a new interest rate. Let's put in our values here in the table that I've created. We have $500,000. The future value of our mortgage at the end is going to be at the end of 25 years, not at 10 years. So we're looking at the end of the amortization period. It's going to be $0. We're looking at the number of years, 25. In a moment, we're going to calculate the number of payments. The quoted rate on the mortgage is the rate that's advertised. It's sometimes called the APR, or annualized percentage rate, which is a rate that should include all fees and costs associated with the mortgage, but does not include compounding. So we're going to have to convert it to find out what the effective rate is. Compounding in Canada for mortgages as well as for bonds is twice a year or semi-annual, and we make our mortgage payments 12 times a year or monthly. Payments are coming at the end of the period, so 0. Okay. So now we have the inputs to our calculation. First thing we need to do, though, is we need to convert this quoted rate into an effective rate using this formula up here in order to be able to calculate what our monthly payments are. So using Excel, we're going to hit equals. We're going to take open brackets, 1 plus, we need our quoted rate, divided by the number of compounding periods per year, which is 2, m. Close brackets, raised to the power of. Now we're going to open brackets again because we need to look at m over f, which is the number of compounding periods, 2, divided by the number of payments per year, f, which is 12. Close brackets. And we have to subtract 1 to get the rate. Hitting enter, we see that 5% with semi-annual compounding and 12 payments per year works out to be an effective monthly rate of 0.4124% or 41.24 basis points. We also need to know how many payments we're actually going to make. It's going to be simply the number of years times the payments per year, which is 12. So we're going to make 300 payments. Now we're going to calculate our payment using the annuity formula. Remember that it's a built-in function in Excel, so we're going to hit equals, and the function is payment, PMT. Opening brackets, we now have to put the rate. Remember that we're going to use our effective monthly rate. Number of periods is going to be 300. The present value or principal amount is going to be 500,000. The future value is going to be 0. And these are payments at the end of period or 0. Closing brackets. We see that our monthly mortgage payment is going to be $2,908. Okay, so let's build out our amortization table. We're going to start with the value of our mortgage, which is $500,000 at the start. We're going to be making our payments. I'm going to change the sign so that the payment appears as a positive number, $2,908. I'm going to make this absolute cell referencing. I'm going to hover over the formula up in the top of the bar, and I'm going to hit F4. That's going to add dollar signs before the column and the row. To calculate how much the interest is, remember it's the monthly effective rate. We're going to take the monthly effective rate, and I'm going to make it absolute referencing, multiplied by the starting or beginning balance for the loan, $500,000. We can see that the principal repayment is going to be the difference between the total payment and the interest expense, and that the end principal amount is going to be the starting amount minus the amount of principal repaid in that month. Moving to the next line, the starting balance is going to be the end balance from the end of the first period, and if I've done this correctly, we should be able to drag down to get the formula. Okay. Notice that it all looks good. The payment is an annuity. The amount that is charged by interest, if I double click on it, it should be, yes, the monthly effective rate of 0.4124% times the starting balance. Principal repayment is actually increasing marginally. You can see it goes up by around $4 from the first month to the second month. And the end principal balance is declining. Okay, so now I'm going to select this and I'm going to drag down, and we should see that at the end of 300 periods, the ending principal balance will go to 0. So I've simply am holding down, whoop, overshot. Let's take a look. Voila. You can see that we have our payment, which is always 2,908. We have the interest portion, which is declining as the beginning balance is going down. Given a fixed payment, the principal amount being repaid is going up. In the last period, it's exactly equal to the starting balance. We end up with 0. Scrolling back up to the top, you may be wondering how much of this actual was interest payments and how much was principal. So I'm going to put in a formula here, a built-in function. It's called sum. I'm going to look it up. Here you see sum, which is basically take the sum of a group of numbers. Now, some will ask you to input the numbers, but what we're going to do is we're going to basically input an array. I'm going to select the first cell, hit Shift, Control, down arrow, and take it to the very end of that column. As you can see, it goes from row D15 to row D314. Hit OK. Now, because it was quite a large number, I'm going to have to widen to see how much it is. Look, $372,000 is how much you're going to pay in interest on this mortgage, which is only $500,000. How much do our principal repayments add up to? Well, I can simply drag across to move the formula across. And as you would expect, the mortgage is $500,000 and the total principal repayments are $500,000. So what this shows you is that over the course of a mortgage of 25 years with monthly payments, you are going to pay a tremendous amount of interest, which is why it's in your benefit to pay down that principal amount more rapidly. That's it. Thanks very much.